So in this video, I want to talk about something called the unit circle and its relation to sine and cosine. Unit just means one, and so what we're talking about is a circle of radius 1 centered at 0, 0, the origin. So we have a circle centered at the origin on the xy plane whose radius is 1. And that is supposed to be a circle. I apologize that it looks more like a potato. Close enough. Okay, so here's the x-axis, here's the y-axis, and this is the point 1, 0, and this is the point 0, 1. As we said, this is the unit circle. You might remember that the unit circle has the formula x squared plus y squared equals 1. If I take all the points x, y, whose x coordinate and y coordinate, when I square them and add them up, give you 1, you get the unit circle. Now, let's go to a point on the unit circle. We'll call this angle right here theta, and we'll go to the point on the circle right there. It has an x coordinate and a y coordinate. The x coordinate is given by cosine of theta. And the y coordinate is given by sine of theta. Now, right now, the easiest way for us to compute cosine of theta and sine of theta for a particular theta is to use our calculator. So let's say we're on the unit circle. We have this circle of radius 1. And we draw this angle of, let's call it 30 degrees. If I want the coordinates of this point, the coordinates of that point are going to be cos theta. That's going to be how far over we are. It's going to be how far over we are on the x-axis, because we said the first coordinate is cos theta. That's the x-coordinate. And the y-coordinate is going to be sine theta. That's how far up you are. So this distance from here to here is cos theta. That's where you are on the x-axis. And this distance up here is sine theta. If you think back to that video I made about the Ferris wheel, you'll see that that's consistent with what I said the first time. Now, oops, I said theta in this example was 30 degrees. So we could put 30 degrees here. And so this is actually 30 degrees, and this is actually 30 degrees. Now you can leave it in terms of degrees, or you can convert it to radians. 30 degrees, we talked about how to go back and forth between degree and radians, between degrees and radians. 30 degrees, you multiply by pi and divide by 180 degrees, and you end up with 30 over 180 pi. 30 over 180 is a sixth. So this is 1/6 of pi, or pi divided by 6. So we could have just as easily have written this as cos of pi divided by 6 sine of pi divided by 6. Now, when you're using your calculator to be able to compute cos and sine, it's important to know whether your calculator is currently measuring angles in degrees or radians. There's a setting in your calculator, depending on what kind of calculator you have, that you can switch back and forth between degrees and radians, and occasionally on a calculator you have a third way of measuring angles called gradients, but usually it's just degrees and radians. So make sure if you want to use 30, make sure your calculator's in degrees. If you want to use pi over 6, make sure your calculator is in radians. But no matter what, you will get that this number is the value root 3 over 2. Now your calculator is going to give you a decimal value, but it turns out to be root 3 over 2. You'll see that root 3 over 2 is the same decimal value as your calculator gives you, and sine of 30 is going to be 0.5, or 1/2. So the coordinates of this point are going to be root 3 over 2, that's the x-coordinate, and the y-coordinate is going to be 1/2, or 0.5. And so you can find the point at any angle all the way around just by using cos of the angle, sine of the angle.